Hello, my name is Jeff Rush, and this talk is a demonstration walkthrough of the IPython interactive shell. Divided into 5 parts, this talk in the 5-part series will cover debugging and profiling your code, then look at executing long-running callables and background threads during your session. Let's get started. And debugging your programs. We talked about the debugger a little bit, but let's go into a little bit more detail on that. Now, when you have exceptions, we have the usual Python exception, but we have other choices as far as the appearance of them. So we have the exception mode and put it into plain mode. And we're going to run calc2. Okay, this program intentionally has a divide by 0, so we can see how exceptions are done. So this is the plain exception mode that gives us a 0 division error. Now we'll put it into a context mode, exception mode, and we'll run it again. And here it actually gives us a few lines of source code around each of the stack levels, so we can see, give us idea where we are here. And then the third mode is I've been doing too much BBSing X modem there. Is the verbose mode. It'll look very similar to the last one, but you'll see a subtle difference. Let's see if you can find it. See, it still gives us the context. The difference is right here, for example, is it tells you what the arguments that were going into this function. So it gives you, without having to query the values of operations, it'll actually tell you what the call values were for each of the operations going in. Another function is PDB, which turns on the automatic calling of PDB upon the occurrence of an uncaught exception. So we can run that calc2 again, and notice the prompt over here when I hit return. We're in IPython here. I run that calc. It hits the exception inside my program and drops me into the normal Python debugger, the PDB, so that I could dig into the situation. I hit Q to get out of the debugger back into IPython. Okay, you can also run inside the debugger, so say run-d and calc2. The difference here is it starts at the beginning, and it drops you in the debugger at the beginning of the program calc2. So you have all your usual continue or whatever options you want, so you can single step through and still get the exception. And then it comes out of the debugger when the program finishes. And of course you may also want to say, just in my current namespace, just take me into debugger now. There's something I need to look at. So you hit Debug Puff, you're now in PDB. So you can go in there when you have an uncaught exception. You can run your program inside it from the very beginning, or you can go into the debugger explicitly. Get out of PDB. There is another option for helping you debug. Oops, not Emacs. We're going to edit the calc2 program. Same as the other calc program, except that this divides by 0 instead of dividing by 2. Now, you'll notice these lines right there. Now, those 3 lines cause your program, when run, to bring up the IPython shell and bring you into it at that point in execution. And you can do whatever you want. You have full access to the namespace. And then whenever you exit the shell, it will continue running your program with that line that we do the division by. So we would uncomment that. Just a moment. We have a permissions error, but I will fix it. into IPython. Okay, now we've uncommented that. So now when we run calc2, now we're in IPython running calc2, it will take us into a subshell of IPython. That'd look very different. But the difference is in the namespace. We now see the A and the B that are about to be divided. And we see some IPython variables. So we can actually see the A and the B and be able to interact with the system call. This is not just for debugging, but also useful for long-term calculations where you want to run some parallel computing process or something and let it run for long minutes or hours, and then you want to come want it to stop afterwards so you can query and explore the data that it's returned. And here I just got back out of the IPython. The difference here also is when you're in IPython, you're not single stepping. You're not really in the debugger. You're simply back into the IPython shell. So it's less disruptive to your running time environment because it's just like letting you peek in the system and then continue running. Now another thing IPython does is profiling. It's close to debugging, but a little different. So you can use the time command. These are functions already built into the library, but IPython gives you access to it. So we can sum up, get a range of 10 million numbers and time how long it takes. And it takes 3 seconds here. We get user time and system time, just like it's your normal shell. That gives a coarse measurement of time. If you were going to time something that was very short, like 1,000 of those, it's done in 0 user seconds, 0 system seconds. Basically, it gives you no useful information. You don't know how long that really took. So we have the timeIt command, also part of the standard library. So we can put in something very short like this. Now, timeIt will actually run it multiple times. It'll automatically adjust itself to it'll run one loop, compute how long it takes, and then set up a number of iterations. So here we find out that it takes 128 microseconds per loop. So we can actually measure very small things, very fine resolution. Okay, so we have going on with profiling. Let's take a look at something a little longer. So let's take a look at Walker. Now, Walker's little program I just threw together from the cookbook that walks a directory tree, looking for files of a certain pattern and returning those. And there's a function here called zopdocs. So especially when I walk the entire zop directory tree and find me all the .txt files and return a list of those files. Okay, it'll take a little while to do that, of course. So let's run Walker. It'll take a moment here. Shouldn't take very long because when last time I ran it, it was very quick. There we go. Okay. So we have all those text files. So we now have the zopdocs function here is now defined in our namespace. So we can time zopdocs faster because the directory entries have been cached. And at the top, I'm paging up. Well, as you see, it's very hard to find things inside that. So remember that semicolon command that says, hey, run this thing but don't show me the output? We can put the semicolon on the end of that. So here we actually get the time. Find out 0.21 seconds and such, not very long. But the semicolon lets us, run the command without seeing the output, and time lets us see the course level. But we also have the timeIt. So it's going to multiple walk that directory tree. We don't need a semicolon because timeIt never prints the output. Time does. So we run timeIt and get a more averaged runtime. Takes a few seconds, but not very long. There we go. So 320 milliseconds for each directory tree walk. That's the so we get a course and we have a find. We also say you want more detail, so we can say, okay, prun. Now, prun runs expressions. It does not run files, but it runs the Python profiler system with all the documentation already you'll find elsewhere. So we run prun on that directory tree walk, and it brings us back in here with per call, per time, which function was it in. So this gives you a lot more detail for profiling. And then yet another way to run your program is run-p with Walker. Now this is the reverse of prun. Prun runs expressions, not files. Run-p runs files, not expressions. So we'll run that into the profiler. We'll get basically the same output, it's just that it came from a different place. And we'll see the output. Okay, no big deal. Now we have another file called GoFetch. Now we're going to what this is going to look at is running things in the background. IPython lets you start long-running operations in the background. These operations are Python expressions. They're not separate files because you could use a system shell for running whole programs in the background. But this lets you run actually expressions in the background. So GoFetch.py is a little program that goes to the python.org site, opens a connection, reads in the page, closes it, and returns the data. It won't take very long, but it will take a pause. So we run the bg command. So we say run. Actually, let me bring it into memory here. Actually, this is how it's going to be looking at it. So you see that. And when we get done, it's GoFetch is now in our namespace here. Right there. So let's run GoFetch in the background. Puff. Job number 0 is now running in a separate thread. We can continue doing other things in our life. And sometimes we say, hey, whatever happened to that job number 0? So we can type job 0 status. It's finished. Remember, it returned the HTML page, so it's going to be a lot of data. So we say, okay, show us the result of that operation we did in the background. And here, as you see, it shows us the HTML from the main Python page. That's it for this part 4 of 5. To download the IPython software, visit the SciPy URL given. You can send comments to me at the address below. Thank you for listening.